Today's presentation is offered by Unipart Rail and Thomson Engineering Design. We have here Julia Mico. She's the product manager in plant at Unipart Rail. Julia is a dedicated and skilled product manager. She leads at Unipart Rail. She leads the yellow plant division with 7 years of experience. She brings a strong focus on innovation and sustainability, which, as you all know, are very important for our industry and for TRACCS as well. She's been effectively driving forward-thinking solutions and implementing environmentally conscious practices. Her commitment to blending technical expertise with practical strategies helps shape the future of the industry and contributes to the ongoing success of Unipart Rail. This is exactly the type of professional we want to hear about. Thank you, Julia, for joining us today.
Thank you, Andrea.
And we also have David Thomson. David graduated as a mechanical engineer in 1984 and began working in the rail industry in 1995. He initially concentrated on structural engineering for rail infrastructure refurbishment. And then in 1998, he founded a small manufacturing company himself to specialize in handling attachments and devices for the rail industry. That company became then Thomson Engineering Design and is now the premier supplier in its field. Now, in 2013, David stood aside from the manufacturing side of the business to concentrate on product design and development. Today, he's responsible for the design team and plays a major role in technical support for the company's range of more than 200 rail maintenance products. So thank you, David, for coming on board and bringing in your expertise. Thank you so much.
You're very welcome. Thank you.
So without further ado, I'm going to pass the baton to you so that you can enlighten us all about the future of global rail renewals.
Let's see if I can share my screen. Please let me know if you can see the slideshow.
Yeah, it's there.
Perfect. So, well, firstly, welcome everyone to our webinar on transforming the tracks and revolutionizing the global rail renewal operations for the future. As Andrea has kindly explained, my name is Julia Mico. I'm the product manager at Plant, and I'm joined today by David Thomson, who is senior engineer at Thomson Engineering Design. So, let's dive right in. To begin, let's look at the global challenges affecting the rail industry today. The rail industry is currently recovering from the pandemic, which has had a widespread effect on operations and finances. Global conflicts have further complicated international comparisons and stability. And additionally, we face inflationary pressures that increase operational costs, labor shortages that hamper workforce availability, and supply chain disruptions that delay projects and maintenance. Despite an increase in funding for rail projects, we are experiencing limited availability of critical resources and materials. This mismatch creates significant hurdles in executing construction and renewal projects efficiently. Much of the global rail infrastructure is aging and in need of renewal. The impacts of climate change, such as extreme weather events, further exacerbate the deterioration of the infrastructure, demanding a more robust and resilient solutions. The pandemic has also shifted consumer behaviors. There is a notable decrease in regular weekday commuters, but an increase in weekend travelers. This change requires the rail network to be available and reliable every day of the year, presenting new operational challenges. In face of these challenges, we must explore innovative approaches to transform our rail systems, ensuring they meet the demands of the future. We now explore how the rail industry is being pushed to achieve more with less. As the traffic on rail networks increases, the strain on existing infrastructure grows. The surge in demand presents significant challenges for infrastructure managers and for maintenance contractors, who must ensure the network reliability and efficiency under a more intense usage. This increase in the frequency and also the weight of trains leads to accelerated track degradation. This necessitates meticulous and regular maintenance to uphold the standards of safety and reliability that passengers and freight operators depend on. With train operators expanding, the windows available for maintenance are shrinking. This reduction in maintenance timeframes forces us to look for innovative approaches that can maximize efficiency and effectiveness within these limited periods. The maintenance workforce is not only shrinking, but also experiencing demographic shifts. These changes make it essential to incorporate mechanization and enhance efficiency improvements to maintain the same level of service with fewer human resources. As the timeframes for essential upkeep tasks continue to diminish, the urgency for innovation grows. We need to develop and implement new solutions that can address these challenges and also ensure that maintenance remains effective and that the rail network can cope with the increasing demands. By focusing on these areas, we can identify and implement strategies that will help us do more with less, ensuring our rail systems remain robust and efficient despite the growing challenges. We now take a closer look at the significant investments that are being made in the rail infrastructure across Canada's major cities. These figures illustrate the major amount of investments dedicated to enhancing and expanding the rail networks, demonstrating a strong commitment to improving public transit and rail services nationwide. If we first look at Alberta, projects such as Calgary's Green Line Phase 1 with a 5.5 billion investment and the proposed Calgary-Edmonton high-speed rail project with an estimated 9 billion investments show the scale of investment aimed at improving connectivity and transit efficiency. On the other side, if we look at Quebec, Quebec City is set to benefit from the tramway project, which is estimated between 4 to 8 billion, but also from significant enhancement of the city's metro network, with the Blue Line extension at 6.4 billion and the REM at 7.95 billion. Going back again to the other side, we have British Columbia. In Vancouver, we see the Broadway Subway project at 2.8 billion, the Surrey-Langley Sky Train at 4 billion, and the Cascadia High-Speed Rail projects estimated at 42 billion. With the aim to enhance all these projects, they aim to enhance the regional connectivity. And finally, in Ontario, we're also witnessing massive investments with projects like the GO expansion at 16.8 billion and the Toronto Subways program at 28.5 billion. These investments are not only about expanding the rail networks, but also about maximizing efficiency and return of investments. Our aim is to focus on improving infrastructure by adopting innovative approaches, ensuring these projects deliver long-term benefits for commuters, businesses, and the economy. Basically, our goal is to build a robust and efficient rail system that meets the growing demands of our cities and supports sustainable urban development. Let's now consider the costs of failure within our industry. When infrastructure faults occur, the consequences are far-reaching and severe. Infrastructure faults can result in significant financial losses and disrupt both the passengers and freight services on a global scale. These disruptions affect not only the rail operators, but also the commuters, the businesses, and even entire economies in some cases. Such disruptions lead to an erosion of public trust and damage the rail industry's reputation for reliability and efficiency. Passengers expect and rely on trains to run on time, and consistent failures can cause a significant loss of confidence. For instance, a report by the Rail Delivery Group revealed that infrastructure faults cost the UK rail industry £1 billion in 2019 alone. This staggering figure illustrates the enormous financial burden of infrastructure failures. And nonetheless, this example still underscores the critical importance of maintaining railway tracks worldwide. Proper and timely maintenance is essential to prevent delays, financial losses, and the negative ripple effects that infrastructure faults can cause. Beyond the immediate costs, the financial repercussions of infrastructure failures include compensation claims to affected passengers and businesses, loss of productivity due to delays, and even potential damage to the brand's reputation. Maintaining and upgrading rail infrastructure is not just about avoiding these costs, it's also about ensuring smooth, reliable, and efficient operation of rail services that societies and economies depend on. Now let's discuss advancements in high output methods that have revolutionized rail renewal operations over the past decade. Rail networks worldwide have invested heavily in specialized on-track plant or OTP designed specifically for rail renewals. These investments have paid off in several ways. Firstly, the use of OTP allows for more precise and higher quality track installations. This precision helps ensure that tracks are laid correctly the first time, reducing the need for future corrections and maintenance. High output methods also contribute to improved track stability. Stable tracks are essential for the smooth and safe operation of trains, especially at high speeds. These methods enhance the overall safety and reliability of the railway infrastructure. By ensuring that tracks are laid and maintained to high standards, we can reduce the risk of accidents and service interruptions. Another significant benefit is the increased capacity of railway lines. High quality tracks can support more frequent and even heavier trains, which is crucial for meeting the growing demand we were talking about before. One of the key advantages of high output methods is the speed and efficiency they bring to project completion. These methods allow for faster renewals, minimizing the time tracks are out of service. By completing projects more quickly and efficiently, we can significantly reduce service disruptions. This is especially important on busy rail corridors and urban areas where even minor delays can have large ripple effects. Many of these high output methods also incorporate sustainable practices. For example, they could be used in recycled materials or they could even be minimizing waste. Both help reduce the environmental impact of rail renewals. However, it is important to note that current solutions do come with some challenges. One of the drawbacks is the current requirement for long possession times. This means tracks need to be taken out of service for extended periods, which can be disruptive. And there's also logistical complications. The complexity of logistics involved in deploying the OTP and maintaining large-scale rails projects adds another layer to the challenge. In summary, while high output methods offer substantial benefits in terms of quality, efficiency, and sustainability, addressing the issues of long possession times and logistical complications is crucial for maximizing their effectiveness. So, continuous innovation and improvements in these areas will be key to future success of high output methods. As we look to the future, our vision focuses on revolutionizing traditional methodologies in the rail industry. Our goal is to streamline processes and optimize resources, accelerating project timelines without compromising safety standards. Our solutions offer lower capital investment, lower operational cost, high output performance, rapid deployment, a modular approach, increased safety, and the digital and automation technologies. In essence, our vision for the future is about making rail renewals faster, more efficient, and safer. By integrating advanced technologies and innovative methodologies, we can build a robust and resilient rail network that meets the demands of tomorrow. In the face of aging infrastructure, rail networks around the globe are struggling to deliver world-class services. Contractors and infrastructure operators are tasked with the immense challenge of executing construction, maintenance, and renewal projects more efficiently, safely, and cost-effectively. This poses several challenges due to the high costs, as both the upfront and the operational costs of equipment are substantial, especially for large-scale projects. Also due to resource demands, as rail projects require significant resources from manpower to materials, which need to be managed effectively. A certain technological dependency, as the machinery used in rail projects is often highly specialized and technologically advanced, which can lead to low adaptability, and operators might find it challenging to adjust equipment to different project needs or conditions. And finally, the logistical complexity of coordinating large-scale rail projects cannot be overstated. It requires meticulous planning and execution to ensure everything runs smoothly. Recognizing these challenges, Unipart Rail and Thomson Engineering Design have joined forces to provide a universal solution tailored for global rail operators and contractors. Our innovative system offers all the benefits of high-output train-based systems, but at a fraction of the costs. Moreover, this system is highly adaptable and can be used on any type of rail line, removing previous restrictions and making it a versatile tool for various projects. This partnership aims to revolutionize the way rail renewals and maintenance are conducted, making them more accessible and efficient for operators around the world. With this being said, I now leave the floor to David.
Thank you, Julia. Before we go on to look at three of a range of machines that we've recently launched onto the market, I'd just like to emphasize some of the key points that Julia's just made. As an industry, what we need to do is more work in less time with fewer people. We need to make the most of short nighttime track possessions, allowing the track to remain open for freight and passenger traffic throughout the rest of the day. And we need to put high output machines in the price range of the tier 3 suppliers. That is key, because that means we can have much more high output machinery available. If we can meet these three challenges, then we can make important advances in track availability and in service reliability. Realizing the importance of these three factors led us to develop a new range of products, and the first challenge we tackled was to develop a new way of laying ties. Thomson have been producing specialized sleeper laying attachments for excavators for quite a while now, and these usually take the form of a grab which can lift a bunch of ties at a time, spread them to the correct spacing, and place them onto the track bed. That works really well. It's highly reliable and relatively quick, but it relies on quite a team of people to help align them and finally position them afterwards. The rate of output tends to be limited by two key factors. The first is the slow cycle time caused by the one operator having to control so many functions on the excavator and the attachment together. And the second is the resulting operator fatigue, which reduces his output as the shift goes on. Our new concept is the SL24104 sleeper layer, which overcomes these issues by taking packs of ties and precisely placing them onto the ballast using a semi-autonomous control system to minimize the operator's skill required and the operator fatigue induced. The machine can be delivered by road and rapidly deployed to the worksite, traveling there either under its own power or being carried by the machine that's used to load it. Within minutes of arriving, the machine can be laying its first ties, after which up to 1,000 ties per hour can be precisely placed. A calibrated measuring system controlled by a programmable logic controller sets the spacing between the ties consistently and accurately, while a highly visible green lamp on the top of the machine tells the loader operator when to place the next pack of ties onto the front deck. Ties are loaded onto the front of the machine using a simple grab and are partially spaced as they transfer from the front section to the sloping rear conveyor. Reaching the rear end of the machine, the ties drop into a precision release mechanism controlled by the onboard logic controller. Because the machine can hold up to 18 ties at any one time, the loader operator has plenty of time to retrieve the next pack and deliver them to the machine. The SL2104 can also be equipped with either GNSS or total station receivers used to automatically steer the machine along the track bed. On the side of the control panel is a display unit which allows the operator to set the tie spacing in millimeters, inches, or as a number of ties per rail length or per mile or per kilometer. For setting up the machine, packing it for transport, and for laying the very first tie, a series of manual controls are provided, and also a pendant remote control unit, which is used to give full manual control of the machine if required. The machine is powered by a small diesel engine, which meets the latest emission regulations and is relatively quiet as well. But this is a modular system designed to allow that engine to be exchanged for alternative power sources as those technologies develop. That is a concept that we've transferred into other machines within the system as well. And the first example of that is our modular rail laying machine or rail threading machine. This has an interchangeable power module, so benefiting from technology as it develops, and it operates at relatively high speed, typically around walking pace, to lift the two rails onto the newly laid ties. Two machines are used, one to lift the rails and the other to draw them in together and place them in the rail seats. The reason, the advantage of doing it that way is that the rails can't touch the ends of the ties as they move into position, and therefore the ties remain precisely positioned and undamaged as this operation continues. Two machines preventing sleeper damage also gives us high output. They'll be worked in tandem by radio remote control so that the operator is well away from any danger, and they follow close behind the sleeper layer to produce a continuous output track laying system to rival the major train-based solutions. Now, the key for tier 3 suppliers, and it's one of the things that Julia mentioned, specialized equipment is sometimes difficult to justify in terms of its return on investment. So the rail handling machine has been designed to be more versatile and will be provided, and is provided, in fact, with a number of optional attachments to carry out other work on the infrastructure, such as you can see here, clip clearing using rotary cut brushes. On the bottom left of the screen, you can see a plough which we use to remove ballast from under DC third rail infrastructure, preventing arcing and consequent power loss. And a specialized trolley on the top left-hand corner of your screen is designed for two operators to ride on while the machine moves slowly along the track, lifting and replacing the rail. The two operators can swap out the track pads as a late life maintenance operation. Once the rails are in place, we need to clip them up. And for this operation, we're developing, this will be launched later in the fourth quarter of this year, a self-propelled clipping machine with modular clipping and declipping attachments so that it can be converted very quickly to work with either fast clip, Pandrol, E-clip, PR401s and the like, or even with Voslo clips. The machine has rubber tracks so that it can get itself on and off the track and becomes therefore completely self-contained, requires a single operator, and it has a semi-autonomous control system, meaning that the machine finds its way to the next tie, does the clips up, and then moves on without any specific intervention from the operator. This is a concept at the moment. I can't show you the proper machine, the full machine, because at the moment the patent work is still being carried out, but it's due for launch at the last quarter of this year. Moving on, these are 3 of a suite of 6 machines which we're developing in association with Unipart, available from Unipart throughout the world. And we believe that these meet the 3 challenges we talked about at the start and offer potentially a very important transition step for the rail industry as a whole. Thank you very much.
Thank you, David. And now time for questions. Any questions?
Thank you so much for your presentation, guys. I'm very happy that you were able to summarize this. If anybody wants to ask questions, you may raise your digital hand or type it in the chat. So I'll give you guys a moment to go ahead and do that. In the meantime, David, I was wondering if you could just tell us how does Unipart and Thomson support products sold in Canada so far from your point of manufacture?
Well, Unipart has a number of subsidiary companies in the United States, and they've appointed specialist staff to support both the US and the Canadian market. They have warehousing facilities in a number of key locations, and will support. And I mean, Unipart are a massive global logistics company, so spare parts support and technical support is part of their day-to-day business.
Sounds good. So no concerns over there at all?
No, none whatsoever.
That's good. So I just wanted to also, okay, give me just a second. Here, someone's thanking you for the innovations, David. So thanks, Magic, for that. And so I've heard about the presentation. As you all know, I'm not traditionally from the rail industry, but I'm curious. How would you get the technical advice on choosing the best option?
Specialist sales, the technical sales staff have been appointed, and all of them have a direct line into our factory and to both our design team and our technical sales team. So we have to obviously cope with the time difference, but we have always traditionally been able to respond within 24 hours to any technical support questions that are required. And usually the way it works for product selection is that the team will visit you and with catalogs and brochures and so on, and a considerable amount of knowledge. And in 99 cases out of 100, they will be able to support the sale directly.
I would also like to add, we do have Brian Livingstone on the call today. He's our sales representative in North America.
Yeah, Brian just put his contact information in the chat. So if you have some more questions afterwards, you can connect with him. But Peter here does have a question that's more specific for you to answer. he says, David, is there a specific size of project that your equipment is best suited for based on price and potential output?
Not really. Typically, works up to about 5 kilometers at a time on maintenance, but the machines are perfectly capable of running continuously, as long as they can be supported with fuel and supplied with ties. And that usually is the limiting factor on site length, is the logistics around the job.
Thanks, David. Peter, if you have any follow-up, just raise your digital hand. In the meantime, we have here Magic's question: would the product be bought or hired?
We only offer the products for sale, but our core customer base tends to be plant hirers, especially specialist plant hirers. And this is where what I was meaning about getting these equipment into the tier 3 companies. So it's the costs involved are so much lower than the giant machinery that they are within the reach of many of the hire companies that then supply contractors as required.
Thank you, David. Magic, he threw a thumbs up. And Terry here has another question. Terry Johnson says, how well do these automated processes hold up when working on track repair and renewal jobs, where, for example, precision of the alignment of parts may be degraded over time?
That's always a challenge. Typically when you're laying ties, you're laying new ties, so you're on freshly prepared ballast. So that part of the cycle tends not to be a problem. Where this becomes a challenge is generally in transposing and recycling rail. The modern clipping systems generally will stand being released and reset in tests we've done about 75 times, which is way more than they would expect in their normal life cycle. And the machines are designed to work with clipping systems that are quite badly degraded, particularly the E-clip system, the old Pandrol system, which was very prone to rusting solid. We've got some interesting technology for removing those seized clips, which I'll be happy to share with people at the show.
Oh yeah, that's right, because you're all going to be at TRACCS Rail Day.
We certainly are.
Yes, so some of the equipment is going to be there for you to see, and we will also have Julia and David and Tom speak at the conference side. Here Terry is giving you a clap. Thank you. Then we have some other questions, and I know there's people with their hands up. Give me just one moment, Naveed and Arash. George is asking, does the equipment set the gauge at the top of rail?
No, normally we rely on the clipping system on the ties to do that. But the rail threaders can be locked to a set gauge, so that can be done, but it's a little bit of a challenge then to steer them very accurately down the center line of the ties. So if you're placing rails on wooden ties that are then going to be spiked, it can be done, but it's a slightly slower operation.
Thank you. Thank you very much. Now here, Brian Helm with Goldschmidt Smart Rail Solutions is saying, actually, thanks for the great presentation. Keep up the great work, pushing for a safer and more efficient service.
Thank you, Brian.
Thank you. George is asking, what happens on the special track work?
I'm not quite sure what George is getting at there.
George, if you wouldn't mind to unmute yourself and clarify exactly what you're asking. Okay.
I'm getting there. I'm getting there. So your equipment works on tangent track, but does it work on turnouts and crossovers?
Not the specific pieces of equipment, no. We do have a product we call Morph, the mobile rail panel handler, which is designed for picking, carrying, placing and fine positioning S&C and plain line panels that have been pre-assembled.
Okay,
George,
thank you.
okay, cool. I was going to ask if that answered your question. Good. So now, Naveed Milani, go ahead and mute yourself and ask them your question. Naveed? Okay, so Naveed, if you can't find the unmute button, we're going to give you a moment and we're going to go to Arash. Arash?
Hi, good afternoon. Thanks, Julia and David. Great presentation. And we look forward to seeing you at TRACCS. I just had a quick question. What are your training arrangement for operators and let's say servicing for the mechanics for the equipment if it runs into trouble?
Okay, a number of options there. All the machines come with parts books and maintenance manuals and operators manuals. We also provide a training pack, which basically is a written syllabus for trainers to follow. And we work with trainers to provide whatever training is required. Unfortunately, we can't normally provide one-to-one training simply because this is a global product and we have limited numbers of people within our organization. But we do provide a lot of documentation and telephone or internet support to help you get it right first time.
Yeah, maybe that's something to look into with local partners.
Absolutely.
If you have enough sales of the equipment. So, thank you.
This is something, Arash, that we are currently looking at. We are looking at expanding our services, let's call them, so that we can support you with training, but also maintenance in the future, and hopefully looking at spare parts if anything breaks down, that sort of thing.
All right, thanks. That's great. Thank you.
Thanks for your question, Arash. Naveed, are you able to ask your question now?
Yeah, sorry, I'm not familiar with Google Meet. Thank you so much,
Not a problem.
Julia, for your informative presentation. Just a quick question. Do you have any experience of your machine in North America, specifically considering the weather here and snow and freezing rain stuff?
Not specifically in North America. We've got a lot of experience in Australia where we have the opposite problem. But we are very, very well aware of the conditions in Canada, and we would be making sure that the machines were ready for that.
Thank you. Appreciate that. Looking forward to see you in the show track days.
Thank you.
Take care.
One of the other things, Naveed, is we do take a modular approach to our machines. So if there is something they currently cannot do that you really, really need them to do, that is something we can look at. David is amazing as an engineer, and we always at least take a look at any issue or improvement that could be done to the machine.
Thank you. I'll contact you.
Thank you, David.
That's fantastic. It's always important to know if you're getting like a product or if you have the potential of customizing something. So that was a good note. Thank you. We have here another question from Majek. He's raised his hand. He or she, I'm not sure. Sorry. Majek?
It's okay. It's he.
He. Okay.
Yeah.
Majek, go ahead and ask your question.
All right. Thanks, David and Julia, right, for your presentation. And I Actually, I'm very interested. I asked the question if it was hire or an outright buy, and you answered it by saying it's an outright buy.
Mhm.
So this is me wearing the hat of the client, right? How long is the asset going to last? And one thing I've experienced with operating an asset is obsolescence management. How do you intend to support your clients after sale for the foreseeable future, seeing that you are a very innovative company and the odds on is you probably would invent another cracker. By the way, I'm a huge fan of what I saw, just to put it out there. So as you're inventing, your customer's item is actually becoming obsolete. So how do you manage his material inventories and spare? And this is me speaking from managing turbines and compressors,
Yeah.
especially in the world of compressors. You can literally agree that you see so many companies like Novo Pinioni and other companies merging together, and people's asset becomes also obsolete. So my question to you is, how does one manage that? And is it that you give a time frame? At what time frame would I need to count my depreciation and let go of my assets? Basically, that's my question.
Okay. So the fundamental design life of all our equipment is 10 years. We, at which point it may require a refurbishment. We support all our products pretty much indefinitely. We're selling spare parts today for equipment that we made right in the first year the company was trading. When we supply a machine, we also offer a strategic spare parts pack. And if the machine is going to be used in remote areas, we try very hard to persuade customers to take that option. So we do enough testing that we believe we understand what the wear rate of all the components is likely to be. So we can recommend what you ought to carry in stock and how long you ought to expect that to support you. But we would, taking the range of machines as a whole, one of the main features of them is this modular construction, so that major components can be replaced very easily as new ones become available. And historically, most of our equipment, if not all of our equipment, remains in service for vastly longer than we'd like. We'd really like to sell it new.
That's a problem that some people would say it's a good problem to have.
Yeah.
Right?
Yes.
Because if your product is so good that then your clients are going to be more inclined to buying it, right?
Yeah.
So
Yeah.
that's good. Very well. I would like to encourage anyone else who would like to ask a question to go ahead and raise your digital hand. So as Julia said, you have your sales representative here. Sorry, Brian Livingston. So you have his contact there. Julia, would you like to share the contact info that you had, that slide, so that people can?
Of course. Let me just reshare again.
Yeah, so that people can take a note of that. We will, of course, connect you all so that you can ask further questions if you or your team have questions after the fact. Then you can connect with the rail plant, with David and Julia, or with Brian Livingston, and they will support you with any of your questions. Thank you so much, David and Julia. I think that innovation, sustainability, and also cost efficiency are key elements that we have to incorporate in our industry. So we thank you very much for your jobs and for the presentation today.
We thank you very
Thank
much
you,
for
Andrea.
the opportunity.
You're very welcome. We're looking forward to seeing you in person at Rail Day. As we said, we have an incredible roster of speakers. You can go ahead and check us out at www.traccs.ca/speakers. And then you will find out everything you need about all the VIP speakers, all the sessions on operations, maintenance, construction, innovation, and also the human element in transit rail. We have some encouraging news in that aspect for the industry. So tune in, get your tickets. It's free to attend. We're looking forward to seeing all of you. And again, thank you so much, everyone, for attending. Have a wonderful rest of your day.
Thank you, Andrea.
And David, Julia, have a good evening.
Thank you very much, Andrea.
Bye
Thank
for
you,
now.
everyone, for
Thank
attending.
you. Looking forward to seeing you. Take care. Bye-bye.
Thank you.
Thank you, everybody. Sorry if I wasn't muted earlier. Thank you.
No worries. Thank you.
George has raised his hand. Maybe we can answer one more question.
Sure.
George, you can unmute yourself.
Maybe it was a failed
Maybe he
reaction
was just
kind
trying
of
to
thing.
log out. Okay. All right. Well, he has your contact info, so you'll be able to connect after the fact. Thanks a lot, everyone.
Cheers.
Bye.
Bye for now.
Thank you. Bye.